I am so happy and to welcome this next keynote speaker, Friederike Otto. And we'll see, there you are, thank you. Thank you so much for taking the time. Some of the work that you do have already been mentioned. We've talked about attribution. How much of this can we attribute to climate change? What is weather? And also research more broadly. And I think this will be a great bridge into our discussion on what we can perhaps even learn or take with us from this first segment into when we talk about climate action or climate preparedness at the domestic level. So please, I know you have some slides and a warm welcome. You're in a room with a lot of people interested in what you have to share.
Thank you very much, for this warm welcome. And so I will very briefly. Sorry.
Please, Friederike, I just assume that everyone knows who you are. I should also mention you're a climatologist working as a senior lecturer at the Grantham Institute for Climate Change and the Environment at Imperial College in London. So I should just mention who you have in front of you if you don't know Friederike Otto.
Thank you very much. Yeah, and I'm leading an initiative that's called World Weather Attribution, and I think you have Maya Wahlberg in the room, and she can stand up and wave, who is also working on that team and doing a huge amount of the work that we do all on vulnerability and exposure. And I'll just very briefly introduce what it is that we are doing and why it might be relevant. To start with, I think, why are we doing this work? It's because when we talk about climate change in the public and particularly in political debates, it's very often about future changes or global temperature goals like 1.5 degrees and 2 degrees. And we see pictures like this, which are, look dramatic, but this is actually not why we care about climate change. Why we care about climate change is this. Because climate change that is already happening now is affecting people's lives and livelihoods, and not affecting in a good way, but disrupting their livelihoods on a very large scale and also taking many lives. And we are long in the era of loss and damage, but often when extreme weather events happen, which is one of the key manifestations of climate change, the changing likelihood and intensity of extreme weather events. We talk about, on the one hand, we talk about the weather, and then on the other hand, we talk about vulnerability, and then maybe in a third conversation, we talk about climate change, but it's not really all brought together. And that's what we are trying to do with world weather attribution. And first of all, we look at all three aspects of the risk: the hazard, the vulnerability, and exposure, and look at what the role of climate change in this is. And I will use the example of heat waves as an example, but of course, everything I say now for heat waves also holds for other types of extreme weather events. So in the last 12 months, we had, Maya is actually running for world weather attribution a trigger, which is she is monitoring humanitarian aid requests and all sorts of other impact-related websites and sources to find out when are actually extreme weather events happen that affect people that are, from a humanitarian point, relevant. And so in the last 12 months, we had about 80 of these triggers for extreme heat events. And we can't do 80 studies in 12 months just for heat, and because we are not that many people, and there are, of course, also a lot of other events that are happening. But we looked at 8 of these roughly 80 events. And this is, I don't expect you to read every word here, but this is where these studies have happened and the headline findings. And you see that out of these 6 that are underlined in slide pink, we found that these heat extremes were so extreme, or the temperatures were so high, they would not have occurred without human-induced climate change. And even the other two, they had a very, very strong influence of climate change. And that means, of course, that they're happening much more frequently. They're much more intense than they would have been, and so pose a much bigger danger than otherwise. So how do we know? And this is really the essence of attribution science, of the methodology that we use. So this is just using a heat wave you probably have never heard about as an example. It was an extreme heat wave that happened last year in October in Madagascar, where the whole month of October really, but in that also some shorter periods, was extremely hot. And that has huge impacts on people, but also on ecosystems. And when we want to find out what is the role of climate change in this heat wave, the first thing we need to do is to define how do we characterize this heat wave? And in this case, we used a very simple characterization in just the whole month of October, the average temperatures over Madagascar. And we found that so then we have the heat wave definition. And then the next step is we need to find out what kind of event is that in the world we live in today. And to do that, we use observations and statistical models and climate models to find out what's possible weather in the world we live in today. So in a climate that's already 1.3 degrees warmer than it would have been without human-induced climate change. And we found, and then we calculate all sorts of possible October temperatures over Madagascar, and that gives us a probability distribution. And I'm not sure if you can see my cursor, but this red curve here gives us a probability distribution. And then for the event that we have observed this year, we then find out what kind of event it is. And so in this case, it's a 1 in 100-year event. So that means in any given year, you have a 1% chance of such an event to occur. That's characterizing the event today. But then to do the attribution, we then, because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, we can take these out of the atmosphere of weather and climate models and simulate possible October temperatures over Madagascar in a world that might have been without climate change. And this is, in this case, what gives this blue curve here that says the 1.2 degree cooler climate. And in this case, we find that actually the event we're looking at this year is impossible in the world that would have been without climate change. It's so hot, it would not have happened without climate change. And you can also see this in the summary figure on the left-hand side, where in the middle we have this one dot for the 1 in 100-year event, but no dot for the 1 in 100-year, for this type of event in a world without climate change. And of course, we can't do this just looking backwards. We can also do this looking forward. So if we would be in a world of 2 degrees of global warming, then we can see, as in these dots on the right-hand side, that this event would become much more frequent and would happen approximately once every 5 years. And we can't only look at the change in frequency. We could also say, okay, what is a 1 in 100-year event this year? And this is what you can see with these burning stacks on the left-hand corner. This event, the 1 in 100-year event in today's climate, is about 25 degrees for the whole of Madagascar. How much cooler would this event have been without climate change? And this is what you can see then in this one. It would have been about 1.5 degrees cooler. So this is basically the main idea behind all event attribution studies. So we found that the event was made much, much more likely without climate change, and we found that the intensity has changed. That's sort of the hazard analysis, and unfortunately that what the main thing that the media is always reporting. But why does that matter? And it matters because heat is a killer. And in Madagascar, we actually don't have any reports on the impacts of this event because no one is monitoring heat waves. There's no awareness of heat waves, and so therefore there are no impacts. But of course, from other parts of the world, we do know that heat waves have huge amount of impact on all sorts of on all dimensions, on human health, but also on agriculture, on the economy, on critical infrastructure, and of course on water. And there are particularly particularly vulnerable groups. They are, for example, in informal settlements. There are people who already suffer from water shortages. There are people who have live in very poorly insulated homes or have no access to other coping strategies in extreme heat, like just cool buildings or shade. And so, of course, heat also impacts particularly construction workers, transport drivers, farmers, and people working outdoors. And this is true for Madagascar, but it's of course true for the whole world. And heat is the deadliest extreme event by a large margin in all the countries where we do have data. So bringing briefly together what we do in these attribution studies. So on the one hand, as I explained, we look at what's the event today and compare it with what would the event have been in a world without climate change. And that tells us just how big the role of climate change is. And we can do that for heat waves, where we always find a very big role, but also for other events where the role of climate change can be quite different. So in some floods and some droughts, climate change actually plays a much smaller role. And that is also important to find out, because it means that at least you can still use the past data to inform what you need to be adapted to. Whereas in the cases for heat waves or so, the past data from observations is really not very useful because the climate has changed so much. So you need to include model data and, for example, attribution results. But of course, what turns an extreme event into a disaster is not climate change or the hazard itself, but it is vulnerability. And the same event can have hugely different impacts depending on vulnerability. So last September, there was a storm called Daniel over the Mediterranean that hit Greece and Libya. And the storm killed 17 people in Greece, but more than 4,000 people in war-torn Libya. And similarly, for heat waves, in cities that have heat action plans, the death tolls can be much lower. So Ahmedabad is a city that had a devastating heat wave in 2010, but then heat action plans have been implemented. And that means that actually a lot of heat death in subsequent heat waves have been avoided. And the best estimate in the scientific literature is that about 1,000 deaths in one heat wave have been avoided. So, and to look at these vulnerability drivers of the disaster, we look at different aspects. So institutional, is there early warning? Do people know what to do with the early warning? Then, of course, physical issues like where do people live, under what conditions? But then there's also a really important one that is also really, really crucial, especially in countries like Sweden, where people don't think that they are vulnerable, or where people are really not aware that heat waves can kill and therefore are very inaccessible for early warnings or questions, or even drills or practices on that. So that's especially in many of the Western countries a big issue, a much bigger issue than social and economic maybe, but also that plays a very big role, especially when it comes for vulnerability from heat waves when people live in poorly insulated homes. So yeah, I'll just close with what we do in an attribution study. We first find out what has happened, and then we look at what the role of climate change is. But then crucially, we put that into the context of what else is happening and what's happening with vulnerability and exposure, and often find that the best adaptation you could possibly do is not building a big dam, or is not anything that you can easily fund with a 1-year budget, but it's really investing in decreasing vulnerability. So I'll stop here. Thank you for listening.
Thank you, Friederike. And I think what you actually managed to do in those minutes was tie together a lot of what we've been talking about here when it comes to vulnerability, when it comes to what needs to be done, and also bridging us over to what we need to do domestically. So that was quite brilliant. Thank you. And I think what you're doing in here in actually modeling and giving us tools is crucial. So thank you so much for sharing this example. And I think we will bring that with us into our discussions after the break. So thank you so much for joining us. And I will again point to, I'm sorry, Maya, but our Red Cross colleague, if you're interested in more on what we are doing together on this, please ask her in the break as well. Thank you, Friederike. I think we used up our 15 minutes.